Hey everybody, can you hear me?
We can hear you.
Awesome.
Yes.
It's 2:45 and we're going to get started now. And this session is called Showing Your Thinking in a Virtual Math Classroom. My name is Matt McLaughlin. I'm one of the staff developers here at the Lincoln Intermediate Unit. I focus on mathematics and social studies instruction. There's a little bit about my educational journey. I'm currently going to Liberty University for an Ed.D. in curriculum and instruction. That's the newest thing going on with me. I'd love to know what grades you teach and where you teach. If you could put that in the chat, that would help me kind of talk about things. Carla, I thought I recognized your name from St. Joe's. Lauren. Well, welcome everyone. We're going to be looking today at what we can do to help students show their understanding of math and have them do so just in case we need to go back to a virtual world. Please, you can unmute yourselves if you have questions, or you can use the chat. I would love this to be as interactive as possible. There's a small group of us. And I want to just kind of focus on what works and what I know works, and we'll go through, and when we're finished, we're finished. I'm not going to try to extend this out if we get done a little early. A little bit about my background. I've taught a lot of different subjects, math, reading, social studies, science, and art. And I've taught in both middle school, high school, and a little bit in elementary. I've taught in both public and non-public schools. So I have a bit of experience with this stuff, and I've taught with that in mind, and with the ideas that we need to really consider how we're going to work with students in this next year. One of the things I need to start with, and one of the things that we all should start with our students, is setting up norms. Especially if we're going virtual, we need to set up our expectations of what students need and what students want, because expectations really drive the way students react towards us. Engagement really is our priority. And when I say that, we want you to feel engaged, we want you to feel part of the conversation. If you feel comfortable with it, feel free to turn on your videos. It helps me to be able to see you. If you don't, that's fine too. It looks different for everybody. So what may be engaging for one group may not be engaging for others. We honor all perspectives here at the IU. That means we will listen, we will talk, we may disagree, but even if we disagree, we will at least honor that those are your perspectives and that's where you're coming from. So if that's how you feel, that's how you feel, and we'll go from there. And finally, we'll always assume good intentions. Good intentions being that we want to make sure that people understand and feel that that we're trying to do our best for people. We don't want people to think that we don't want to, everyone is not pushing in the same direction and doing what's best for kids. Remember that we need you to do your evaluations by July 31st. And if you're one of the first 100 registered and you do your evaluations, you'll get the books. That's how we get your address of where to send it. So when we start thinking math, and this is one of the bedrocks of what we do. Sorry, I didn't go over the outcomes. And it looks like I forgot to put that slide in. The outcomes for this one, the ones that we're looking for, is for you to find tools and methods for meeting students where they're at and having varied methods of identifying how students truly understand mathematical processes. So for that, we need to start thinking about what is mathematical instruction. And if you are one of our literacy people, you know the reading rope. Well, Kilpatrick and his team came up with the 5 strands of mathematical proficiency. The first being a conceptual understanding. And when we teach, we tend to teach in math the procedural fluency. This is how you add. You take the first number and you move beyond the first number. We tend to live in that procedural step by step. You know how to do it. We can do these things step by step by step. Well, that's not all. What the studies have shown is that we need conceptual understanding, that students need to go beyond being able to just do the problems, but they need to be able to understand what is the underlying force behind the problem. Why are we doing these steps? If you're in middle school, same, change, flip comes to mind. Or the order of operations, that's important. You can follow order of operations and it will work, but why does it work that way? We need to have students answer the question of why. What is the conceptual basis of what it is? Procedural fluency is that students can do the problems, that they are efficient at doing them. And efficiency means, in a lot of ways, time and correct, that they are both fast and correct. And that's a really big, important piece to this. Strategic competence is that they can use strategies to solve both familiar and unfamiliar problems, that they can look at it and say, okay, this one looks like this an addition problem, or this looks like a multiplication problem. I'm going to use those strategies. Adaptive reasoning is that they can logically think through problems. They can reflect, they can explain, they can justify. And finally, the hardest one is the productive disposition, that they believe that they can be math students. If you're here all 3 days, I'm doing a session on one of the days for math identity, and this idea that of people understanding that they are math people, and that we need to get kids to really understand that they can be math people and working towards making that mindset. So that is another key piece to this. So one of the questions when we move over to virtual, what do we need to teach skills? What are things that we need as teachers to teach math virtually? And I'll let you guys answer the question, and I'll answer it again a little later. There's a series of questions. So what do you really feel that we have to have for us to be able to teach students math online? Thank you, Lauren. Lauren says foundational skills. Sherry, that is very close to my heart. Common vocabulary. I just saw it's in one of my other presentations, I believe, that all students are math language learners. We have to have some way for instruction. And we really do need to know the different resources. My next question is a little deeper. How do we get students, do we have students show conceptual knowledge in a regular classroom today? And how do we get them to show it virtually? Think about the classrooms you've been in. Do they talk about why they're doing things? Or is it more of a, that's the correct answer or that isn't the correct answer? And that's the thrust of what we're going to do, is showing the conceptual knowledge. One of my other questions is, what can we honestly assess online? This has been something I've seen a lot of teachers ask. How do I do math assessments and know that students who are taking these assessments are the ones doing it? Okay. Whiteboard demonstrations, 50-50 on the conceptual knowledge. And the last one is, what is the biggest concern we have in moving to, if we have to move to virtual? Or if we choose to move to virtual? I feel that, Lauren. The hands-on instruction. Concrete understanding. Because that's so important, the concrete part. Okay. I think I'm going to cover almost all of this. And especially in learning support and other groups, when we talk virtually, we need to really consider the time that they're going to spend in the learning support and the grouping that we do. And they need to be flexible. As we know, they need to be malleable, and we need to make sure that there is time set aside to support those students. So one of the big things that I'm a big believer in is document cameras, especially for virtual learning. And I don't have my document camera here today. I'm kind of regretting that I did not grab it when I left. But a document camera could become one of the key methods that we look at for instruction in this new kind of age of virtual instruction. And not everyone has one. One of the greatest things about a document camera is that you can do the problem with the students real time. One of the things you said was, or one of the things that I read that you said was your concern about visualization, about being able, students getting the hands-on work. They can follow along with a document camera much more efficiently. But what if you don't have a document camera and students don't get to see your writing? One of the things that, an inexpensive way of handling it, is the company IPEVO has the ability for you to have a document camera. This over here has the ability for you to have a document camera via your cell phone. It's $20. I checked it today. It's $20 all told to download the app for it to work forever on your phone. It turns it into a basic document camera. Their cheapest one, I know IPEVO is not the cheapest one out there, but one of their cheaper ones is about $100. But they are, the entry model is about $100. You can get them for $50. You can put a webcam on a stick, honestly, and that would work. But this works for you to be able to get those more concrete examples. And it allows you to also think about how you are going to push out information to students. A document camera could be as something simple that your school could work with you on. And if kids are coming for lunches, which a lot of schools are, it's powerful for you then to maybe give them manipulatives that they can cut out or on paper that they can use. And they can follow along with the same ones you're using on the document camera. And that's one way of getting that concrete. I'm a big believer in having students take pictures of their work. That is going to be one way we can really get to know what students are doing, is by taking pictures and being 100% clear with that. With that being said, sometimes it doesn't work well, or we have other issues with the pictures. If you've ever seen one of these, they're called a rocket book. It's a notebook that has a code that you can use your phone to scan what they write into. And it uses the Rocketbook app that they can email whatever they write on there. And what's really cool about Rocketbook is one of the things they did is they created PDF versions of everything that they do. So you can have the kids do the PDF version, and then they can write on it and scan it up to you. That's one option. Another option could be as simple, if you're not going to use the Rocketbook stuff, which is, this part is free and the app is free. You could also use any picture, as long as they can put it into your LMS and you can get access to it. That's really the key when it comes down to it, is to make sure you have access. So being able to show you information, if I'm working in small group, I may just have them hold it up onto their video and ask them to show it to me on video. And with saying that, I might do a flip grid. Have any of you used flip grids? Some for grad class. So Flipgrid is a really awesome program, and students, they don't need to log in. You can give them a code for them to do it. It works in Google Classroom. It works in a number of different things. And what they do is they can take a video of themselves talking about what they do. So you could have them hold up what the assignment was, and then talk through why they did it. And then you can watch the video of them talking about it. And you can also set it up that they can respond to each other. So what happens is you create an asynchronous conversation around the conceptual understanding in math. And it really it really will end up showing their thinking when it comes down to it. Students can respond to each other, they record themselves, they can record themselves multiple times. I find myself doing that because I don't like sometimes how I say something. So I'll record myself multiple times and so the way I want it to be said. The only thing I would say to you is just check with your district before you start using video, especially of students. Since this saves to the cloud, and I know that it's a encrypted process, it's a good program, but I would definitely just double check with your administration and your district policy before using it. I never want anyone to get in trouble for something I've suggested, and this would be one of those situations. Beyond that, I really want to make sure that students have the ability to show how they thought and explain how they thought, because I can look at any problem and say, okay, they got it. But the issue is, one of the big concerns is that they're not getting help from others. And that's the deal when it comes to the explanation. I need a lot more information than I did it right. I need to know why you did each step. Small groups. Do you guys use Zoom or Hangouts? I'm just getting 3 Zooms. Anyone else? 4 Zoom? Okay, Zoom seems to be the big one. So Zoom, when we create breakouts for students, we want to be sure that we're outcome based. I am putting you in a breakout room. I want you to talk through how you would solve this problem. And I may give you a problem that may have the information. I want you to come up with 3 questions that you could answer using the information in this problem. That's what I want you to do. That's the outcome. I'm going to give you 4 minutes to do this. I may give a visualization. I may put it on, I would probably put it in like a Jamboard, a Google Jamboard, or I might put it on my Zoom, or I might send it out as a Google Doc so that they know exactly what I want from them. I am going to ask you to report out on the 3 questions on this document. I'm going to always want them to have some form of reporting out as they're working. That is so important. And when we look at this, have you used the breakout rooms in Zoom? Yes, no. I am going to create 2 breakout rooms, and I'm going to automatically assign them to you so you get a feel for what this looks like and what this feels like. And then we'll talk a little bit about what it looks like from my end. So I'll send you to the breakout rooms. I think we have everyone back. Yep. So breakout rooms are awesome. This was my view when I put you into the breakout rooms. I was able to see who was doing what, when. It really helps. I could have done these much more intentionally where I picked each student. I can set it up that I have certain students that I work with ahead of time. And in the breakout rooms, you have the ability to have a whiteboard. So one of the things that I would train students on is the whiteboard. And so students could draw out what they were thinking and put their math equations directly on here and work together on a math problem on the whiteboard itself. So that, and I was able to, if you noticed, I was able to jump into the rooms and listen in on the conversations. Especially if I'm team teaching, that may be something that I would do, is that myself and the team teacher, we would have the two rooms and each of us would take and jump into one of the rooms. So we went from the main room, or one teacher would stay in the main room to answer questions as students came in and out. And another, the co-teacher would jump into one of the two rooms and jump between the rooms to assist students as needed. Both of those would allow me to have some idea of what is going on in the classroom. And I would have a clear understanding of kind of where students were at. And I could also send a message, and I normally did when I run breakout rooms. I normally send a message to all about a minute or two before I decide to close the rooms, just so that they know that they need to wrap up. Because honestly, how quickly do people get off tasks, especially teachers? We all like to talk. This is one of my favorite quotes recently. All students are mathematics language learners, regardless of their level of English language proficiency, and Discourse allows all students to develop mathematical language. I found this, Dr. Singh, or put this up in one of his presentations in PCTM. And I just glommed onto that because it is so true. I want them to talk, but I also want to really have them use mathematics language. I am going to specifically talk in math terms. When I speak to students about math equations and math expressions, I'm going to be extremely specific in how I speak. I want them to gain a math language proficiency that's a math academic language. I like equation. If you're one of those people, number sentence is in the K2 vocabulary for Pennsylvania. I will normally use number sentence or equation in K2, and then really just equation from then on. I understand the reasoning behind it, but if we want kids to learn what an equation is, it's an equation. One of the things someone once said to me was, kids can't understand the word equation, or they can't say the word equation. My response kind of is, if they can tell me all of the differences between a Triceratops and a Stegosaurus, and say Stegosaurus and Triceratops, they can say the word equation. Sorry. But we don't want to assume kids know math vocabulary. We have this thing, just because we know it doesn't mean they know it, and we need to really work on math vocabulary. And for this, I would suggest Quizlet Live, which is something you can do. Also Kahoots. I had high schoolers playing Kahoots, and they thought it was the greatest fun in the world. If you want to play Kahoots, do it. We really need to make sure that we give kids the chance to be kids and play. And if we can do it through a virtual mindset, that is awesome as well. One of the things when we look at math discourse and we have kids talking, we need to do a lot of planning before we have kids talk. We need to know what are their possible responses. Are they engaged or are they not engaged? Think about working from home this last year. How much of the time that you were online was engaged time? How much of it was you specifically working, or how much of it was you being on Zoom, but sitting off to the side with your cell phone right outside the view of the screen and looking at Facebook? How much of your students are that way? We want to have students present. So one of the things that I'm looking for when I go through and look in the breakout rooms is I'm looking for specific ways I want them to show me that they understand it. So I may pull in 2 or 3 kids to present because I specifically want their items. I'm also going to need to keep track of who I have present. If I always have the same kids present, I always hear the same voices. And if I always hear the same voices, I think everything's okay. And the kids that want to present tend to be my higher flyers. I need to make sure that I know where all my students are. And I may see that a kid is great up to a certain point, and I may just have them present the part that they got right. And that is so I don't destroy their math identity in some cases. Because if everyone tells you you're always wrong, are you going to want to try? And I'm going to connect where they're at with things. I want their responses to match what's going on. I may give kids the answer. Here's the answer. Tell me how we get there. We put so much stress on getting the procedure correct that we don't teach the concept. And the concept is key. The key here is that we need the conceptual understanding built in so that they tell me how they got there. And then they can visualize it. Then they can show me. I may have them write out a script of what they're going to say. And the script is what I grade. I may have them write out their thoughts. Or I may do something like this with kids. Hopefully it works. One of the things you guys talked about, do you know what CRA is? Concrete Representational Abstract. One of the things that we get, and I put this in the middle schooler mindset, is that we get people saying, we need to use manipulatives. Well,
in this video, we're going to talk about simplifying expressions. And we're going to do that in relation to a CRA sequence of instruction. Specifically, we're going to be looking at the concrete and how that ties up to the abstract. So when we think about simplification of expressions, we're really talking about 2 things. We're talking about combining like terms, and we're talking about the distributive property. And so those are the 2 things that we need to be able to model for students to help them simplify an expression. So those are the 2 that we're going to take a look at, combining like terms and then the distributive property. If we have the expression 2x minus 3 plus 4x minus 6. In this expression, we have 4 terms, and we're going to model this expression term by term. So we are supposed to model a 2x. And so that is a positive 2x. Now, kids typically see this as a minus 3, but when we are interpreting this term by term, this term is a negative 3. So we are going to model that with 3 negatives. Then we are supposed to have a positive 4x. That is our next term. So we're going to model that with 4x's. And last, we have negative 6. So that's going to be 6 negatives. So as you can see, once again, we're using our algebra tiles, and our longer pieces represent x. We've modeled each term as it is: 2x, negative 3, positive 4x, and a negative 6. Now, to combine like terms, one issues that kids face is that they forget about this negative sign. They move the 6, but the minus sign just stays there. Or they want to put a 3 with a minus 6, and so they'll get negative 3 instead of seeing this as a negative 3 and a negative 6 that are being added together. Here's where the manipulatives help. Because the positive and negative aspect is embedded in the color in terms of our definition, the negative sign travels with the manipulative. So if we want to show the commutative property, all we have to do is move our pieces. And so just by moving our pieces, and I'm going to keep them separated here for a second, just by moving our sets of pieces, we can see how we reordered this, and we could interpret as a positive 2x, a positive 4x, a negative 3, and a negative 6. And now the sign travels with each term. So it helps reinforce that skill for students. And then when we combine like terms, we use the same rules that we did for adding and subtracting integers. I have positives and positives that I'm adding together. That's just...
So one of the things that we need to think about is how can we bring that over to a virtual classroom? This was done with a document camera and manipulatives. I can print out a couple pages with large rectangles and small rectangles with positives and negatives. That would work. I can send those home. The kids can cut them out, and they have manipulatives at home. Or you can ask, hey, if you have cereal, like there's a ton of different ways that they could use found objects for that as well. And that's one of the keys here is we want students to be able to use those manipulatives, get those hands-on, but I need to do stuff so that they can see it. And then they can draw it, and that's the basis behind concrete representational abstract, is that we build it first with manipulatives as much as possible, and then we build it in the rest of the way with the abstract. After I have kids talk with their groups, no matter what it is, if I show them a video or we do a problem, I want them to write their thoughts. And I want them to write. One of the things that we hear about is TDA, especially in the upper grades. But when we think math journaling is so important. Having them show multiple methods that they could use to solve it. This gets that last reflection piece back in. I want them to draw pictures. I want kids to have as many ways to show me how they're going to do things and have the summaries. And I want to have those at the end. I want images of those, and that's how I'm going to show that kids get there. That's kind of the thought processes and the methodology that I've been thinking. What questions, thoughts, issues are you facing? I think I hit most of what you asked for that you were thinking about. So please turn on your mics or put in the chat if there's any other questions or other resources that you have. Sorry, I have the chat on the right-hand screen. That's why I keep looking over there. thank you so much for coming to day one. We really do appreciate it. We appreciate that we had the response that we did and that we could get the speakers that we were able to get. Please make sure to give us the evaluation. I'm not going to hold you any longer. I know it's been a long day in front of Zoom. So have a wonderful day. Feel free to email me at the IU email address. I put it in the chat. I would be more than happy to talk math or work with math with you. And earlier on, my Twitter handle's in there. I only tweet math stuff and social studies stuff. So if you're interested in that and equity stuff, I would be more than happy to have you follow, and I will probably follow you back. Have a wonderful day.
Good job.